Okay guys, hope you're doing well. We are up to 3.9 now, properties of logarithms. I hope you're not going crazy with all the exponential logarithm stuff. Logarithms have properties that you generally learn how to manipulate in Algebra 2, and then in pre-calculus, again, you go over it again and ideally do a little bit more with it. So we'll see how far we go into this. But before I get to that, I want to talk about other properties in math that you already know about, namely properties of exponents. You start learning about this in Algebra 1, and then you see it again in Algebra 2, and possibly even in geometry. So this should not be new at all. This is review. One is called the product property. When you multiply like bases together, the rule is you combine the base and add the power. If that doesn't make sense, it looks like this. If you have x to the fourth times x to the fifth, it becomes x to the ninth. Have you done math like that before? You should have. That's a very common algebra, method, tool, whatever, property. Similar to that is the quotient property. That one says when you divide like bases, you combine the base and subtract the powers. So for example, if you have x to the seventh over x to the third, that works out to be x to the fourth. You just subtract 7 minus 3. There's explanations and lessons behind this. That's not the point of what we're doing right now. We need to get into something new and different, but it's related, so I just want to at least mention it. The third one is the power property. If you have an exponent raised to an exponent, you just multiply the exponents. So if you have x squared to the third power, that works out to be x to the sixth. So those are three. There's like 7 different properties of exponents, but there's the 3 main ones: product, quotient, and power properties that you already know from algebra. Logarithms also have properties, and they have the same 3 names: product property, quotient property, power property. The product property starts like this: log base a of m plus log base a of n equals. And what happens is you can combine these into one logarithm, log base a, of m times n. The two logarithms, the two arguments, get multiplied together. The logarithms combine into one logarithm, and the arguments get multiplied together. The quotient property, log base a of m minus log base a of n, combines into one logarithm, log base a, and now it's m divided by n. So 2 logarithms combine into one logarithm. When it starts out with subtraction, it finishes with divide. So it's called the quotient property for divide. Third is the power property. If you have a logarithm of a base raised to a power, it becomes that power times the logarithm. So it's like this power gets transported out in front of the log. Now, up here I did examples of each one. I don't have examples here because that's what we're going to get into down below. Now, we primarily use properties of exponents to condense or simplify expressions. That is, you start with something like this, and you finish with something like that. You almost never start with this and go backwards in that direction. It's just not a thing that typically happens. However, with logarithms, you can condense or simplify expressions, but you can also expand them. So these properties here can go in that direction, simplifying, or it can go in the other direction called expanding. And we're going to do both of those when we get to the homework. All right, so here goes. The first set of problems are expanding. I'll go through these examples hopefully kind of slowly, and you can pick up on what we do. And you'll see problem 1 is like 2, 3 is like 4, 5 is like 6, 7 is like 8, etc. So I'm introducing it this way that hopefully it doesn't confuse you. So we need to expand this. We need to decide which property up above applies. Well, we've got a power here, so I'm going to use the power property. That is, you can bring this power in front and make it 2 times log base 9 of 3. And that's it. It is now expanded. You don't pick up a calculator and type this in and work it out. That's not part of the expectation. Let me check the answer. And there it is. We have just expanded the logarithm. Well, that's going to be a lot of scrolling up and down. Looks like I gave you way more space than you need. Oh well. Number 4. So here we start with division. Division is this one here, the quotient rule. So we are going in, or quotient property, in this direction. So according to this, we need to split it into logarithm minus logarithm. So it's going to be log base 9 of the top number minus log base 9 of the bottom number. So we expand this quotient into essentially a subtraction problem. Let's check number 4 and see, yeah, there it is. Number 6. Okay, 6 is kind of special. Here's something you got to dig deep into your memory from Algebra 2. A square root is the same thing as a 1/2 power. When you do this problem, here, I'll get you started. A cube root is the same thing as a 1/3 power. So roots are essentially fractional powers. The index of the root is the denominator, and then unless something else happens, the numerator is a 1. So here, log base 5 of the square root of u is really log base 5 of u to the 1/2 power. So that's power, just like number 2 was. We started with a power right here. We're going to use the power property. We're going to bring this 1/2 out in front. 1/2 log base 5 of u. And that is correct. Now, I know that the answer key is going to look slightly different than this. The answer key is going to be log base 5 of u over 2. If you think about it, hopefully that makes sense to you. Pick any number, any even number, just make it easy, like 16. Multiply it by half. And then do 16 divided by 2. You get the same exact answer, because multiplying by a half, you put this over 1, you do top times top, bottom times bottom, and it's the same thing. So multiplying by a half is the same thing as dividing by 2. So if you get an answer that looks like this, you check yourself, it looks like that, it's the same answer. Let me just go down and make sure I'm not talking a bunch of garbage right now. Yeah, there it is. Okay, number 8. Log base 4 of 10 times 11. Here is times. That tells me I need to use the product property. Times means product. Right there's the times. So what is it? You make it log base 4 of the first number, 10, plus log base 4 of the second number, 11. And that one looks funny. I better fix that. So log base 4 of the first number plus log base 4 of the second number. There it is. Let's check number 8. Voila. Number 10. Why are there so many of these? Well, because you can mix and match these properties together. Now, before I do number 10, I am going to simplify this power. When you have 3/11ths to the 6th power, it's actually 3 to the 6th, 11 to the 6th. Now that we've done this, I can take the division and do the quotient property. Log base 6 of 3 to the 6th minus log base 6, 11 to the 6th. So that was the quotient property. Let me scroll back up to the property, and here it is. The quotient turns into a subtraction. Okay, but we're not done. Where is it? Right here. Because both of these logarithms have powers, we can do the power property, which allows you to put that number out in front of the logarithm. So 6 times log base 6 of 3 minus 6 times log base 6 of 11. This is what we would consider a fully expanded logarithm. Let's check number 10. And there it is, exactly the same. All right, let's try number 12. See how we've combined logarithms together. Okay, combined properties together. This xy to the third, xy is times. Times, I can use the product property. Log of the first one plus log of the second one. That's the product property. But the second term here has a power. So I can now do the power property. Log of x plus 3 log of y. And that should be fully expanded. Let's check number 12. There it is. You can see there's a lot of problems. I apologize for that. It doesn't feel good when you see so many problems that you have to do, but these are tricky, and the more you do, the better it is, and you kind of have to work your way up to the more difficult ones. That's why I start off with several one-step problems, and then start getting into two-step problems, and then they get bigger and bigger. Number 14. Well, again, before I do any of the properties of logarithms, I can simplify this and make this log base 5 of a to the 20th times b to the 5th. So I can apply this power into those parentheses. Now I've got a product, so I'm going to use the product property, log base 5 of a to the 20th plus log base 5 of b to the 5th. But each one of these has a power, which will allow me to do the power property. 20 log base 5 of a plus 5 times log base 5 of b. And that is, or should be, expanded if I did it all right. And there it is. So yes, there are a lot of these. When you get good at it, when you get it down, they do kind of go fast. All right, this one is really, really something. First of all, we have a quotient here, so I'm going to do the quotient property. Log base 9 of 11 times 12 squared minus log base 9 of 7 to the 3rd. This means I can do the product property. That times is a product, so I can split this into log base 9 of 11 plus log base 9 of 12 squared, and then bring down log base 9 of 7 to the 3rd. Now you might ask, couldn't you have just done this one step instead of two, done it in one step instead of two, change this to a plus and change that to a minus? Yeah, you could have. You can streamline this when you get good at it and combine steps, but I felt it would be smarter as an instructor to break it down into one step at a time. But we're not done. Why not? There's a power here, there's a power there. I can do the power property here and the power property here. So bring down log base 9 of 11. You cannot really expand that. And then it becomes 2 times log base 9 of 12, and then 3 minus 3 log base 9 of 7. So here we've got a problem that involves all three properties at the same time. Break it down into steps and expand it. And then check it and hope you didn't mess up in front of your whole class. Right there it is. And I didn't totally remember it. Yeah, that looks right. Okay, so the first whole group of problems are expanding. The next set of problems are condensing. Let's look at number 8. We've got a number times a logarithm. We can use the power property to stick that number up here and make it a power. Log base 2 of x to the 5th. And this is now considered condensed. Log base 2 of x to the 5th. Next one. Log base 9 of u over 2. Okay, now this is what happened before. Over 2 is the same as 1/2 times. So 1/2 times log base 9 of u. I can now make that half a power. Log base 9 of u to the 1/2 power. And then don't forget that fractional powers are the same thing as roots. 1/2 power is square root. So that's log base 9 of the square root of u. Let's check log base 9 square root of u. As you can see, the one that you are going to do is going to be a 1/3 root or a cube root. And that's probably, yeah, because it's divided by 3. Number 22. This has a minus in it. Go back and look at the properties. Which property has a minus sign in it? That would be this one. There's a minus sign right there. So that tells me I need to use the quotient property. To use the quotient property, I condense these two logarithms into one logarithm, log base 8, and then it's simply the first argument, 10, divided by the second argument, 3. And that should be the answer for number 22. And there it is. Next one. This one has a plus in it. That tells me it's going to be the product property. Without scrolling up and down and getting you all dizzy, you condense it into one logarithm, first argument times second argument. Log base 4 of v times u, or just log base 4 of uv. Let's make sure 24 is right. vu, uv, same thing, it doesn't matter with multiply. With divide, you'd have to have the first one on top, the second one on bottom. That's critical. But with multiply, uv and vu are the same thing. All right, number 26. Well, first, I have a number multiplied by that logarithm. I can do the product property. So I get log base 9 of 6 plus log base 9 of 5 to the 5th power. Now I can focus on the plus sign and condense this into a product, 6 times 5 to the 5th. Maybe put that in parentheses there. And that should be the answer to number 26. Indeed it is. Number 28. Okay, both of these logarithms have coefficients, numbers in front of them, numbers they're being multiplied by. So you can do the power property on both of them. Log base 7 of 11 to the 6th power. Got to make that look more like an 11. Minus log base 7 of 12 to the 2nd power. The minus sign here, the subtraction, tells me I can condense this using the quotient property. There's my fraction bar for the quotient. 11 to the 6th on top, 12 to the 2nd on bottom. That should be the answer to number 28. 11 to the 6th on top, 12 to the 2nd on bottom. And let's look at 30. Oh my goodness. Well, first thing I'm going to do is rewrite this as 1/2 log base 9 of a. Remember, dividing by 2 is the same as multiplying by a half. When you see that it's multiplied by a half, you can make it a power. So log base 9 of b plus log base 9 of c plus log base 9 of d. Oops, I messed that up. That was supposed to be a d. Plus log base 9 of a to the 1/2 power. Wow, that's a lot of writing. Now, since these are all adding, I can do one big product property and make it b times c times d times a to the 1/2. So essentially, excuse me for that, each plus sign condenses into a product. And then last but not least, remember that a half power is the same thing as a square root. So that's b, c, d square root of a. And that should be the answer to number 30. And it is. They did wrap it in parentheses for whatever reason, but that's fine. Okay, so your exercises are like mine. If you just kind of follow the pattern. Okay, it looks like these two are switched as far as similarity goes. But other than that, you should be able to use my notes to help you along with this assignment fairly well. If you do have trouble, let me know. I'll address it during our live Google Meet session, or I'll email you, or whatever needs to happen.